This is the first section on chapter 2, which is on Argand diagrams. I think this is a nice, easy, straightforward chapter. Maybe some things on loci that get just a little bit more challenging, but basically it's a way of displaying a complex number basically on a coordinate grid basically. So an Argand diagram is like a coordinate grid. Yeah. Now a coordinate grid is what we call a Cartesian grid or Cartesian plane, and Cartesian basically means x and y. So a Cartesian grid, which we've been using all our times, is x and y. Okay, an Argand diagram uses real here and imaginary here. That's the only difference. So this is called an Argand diagram. And we can plot our complex numbers by basically either as a single point or maybe like a vector. So if I had something like this, and this was 3 across, and this was 2 up, that would represent the complex number 3 plus 2i. It's as simple as that. Now, these parts of the grids do go to negative, so you can show negative complex numbers. So if I had, I don't know, a different one that went over here, and the top of it was at 3, and this bit here was -6, then this would represent the complex number -6 plus 3i. Yeah, very, very easy. Show the complex numbers, 4 of them on our Argand diagram. Now, it doesn't need to be a perfect diagram. Just try and draw it as neatly as you can. Probably want to draw the axes with a ruler. So real and imaginary, that's fine. So we need to do, so first one, -4 plus I. So -4 and 1. So I can represent it as a single dot. So I might decide I'm just going to do that as the way that I'm going to display it, or I can display it as like almost like a vector, an arrow, which goes like that. Yeah, so you can do it either way. I want to do it as an arrow. So this is Z1. Z2 is 2 plus 3i. So 2, 3 up. As I said, this is not to scale. And that will be 2 across 3 up. So it's going to be an arrow that goes, well, it's going to be a better drawn arrow than that. It's going to be something like this. So this is Z2. And the last one is 2 minus 3i. So it's going to be 2 across, and it's going to be 3 down. So it's like a reflection of Z2 in the y-axis, x-axis, sorry. So it goes down there. So there's Z3. Done. And as I said, you do have the option, instead of arrows, if you want to draw them as arrows, we can draw them as a single point, like this, this, and this. Well, we've got some other ones to draw on an Argand diagram. Here. So my imaginary axis, my real axis, and I'm drawing Z1 and Z2, so 4i, 4 across, 1 up. So that is Z1. Z2 is 3 plus 3i, so let's call this 3 and 3 about here. As I said, none of this is to scale. Really, it's sketching, yeah, or showing. It's not plotting. Right, so what's that? 3 and 3, so it's going to here. So it's going to look something like this. That's Z2. And then we need to show Z1 plus Z2. So Z1, which is that, plus Z2, which is this. That's going to be 7 plus 4i. So 5, 6, 7 there, and 4, let's call this 4. So that will be going up to about here, and that ends up like this. So this is Z1 plus Z2. So you can see geometrically what happens when you add two complex numbers. It's basically like Z1 plus Z2 is like the diagonal of this parallelogram here. Yeah, so that's a geometric way of interpreting what Z1 plus Z2 is. Another Argand diagram. And we're plotting similar to the last one, but now it's a subtraction. So 2 plus 5i. 1, 2. Now I'm going to have to make this scale a bit smaller if I want to go up to 5. 1, 2, 3, 4, 5. There. 2 plus 5i is going to go up to roughly there. So we'll draw that in. So that is Z1. Z2 is 4 plus 2i. 3, 4. So 4 plus 2i is going to be like here. Z2. So let's put these numbers in. 1, 2, 3, 4, and 5. And then we need to work out Z1 minus Z2. So that's Z1, 2 plus 5i, minus Z2, which is 4 plus 2i. And what you get here, so 2 minus 4 is negative 2, and 5 minus 2 is 3i. So we now need to plot negative 2, negative 1, negative 2, 3i. So that's going to be going like here. So Z1 minus Z2 ends up over here. Now, how do we interpret that geometrically? Well, if we look at Z2, we were doing Z1 minus Z2. Minus Z2, if we reverse the signs of the real and the imaginary. So let's do this. Minus Z2 would actually be, not Z squared. If Z2 is 4 plus 2i, then negative Z2 or minus Z2 would be minus 4 minus 2i. So you could think of the question as being Z1 plus negative Z2. Now we know how to interpret adding. It's like that parallelogram. So could I interpret this as adding Z1 and negative Z2? So Z2 would be negative 4, negative 2i. So I'm going to have to put negative 1, negative 2, negative 3, negative 4. So negative Z2 would actually look, I'm doing it in this green colour, which actually looks something like this. This is negative Z2. And actually we can interpret it in the same way in terms of the parallelogram. Let me sort of just draw this on so you can see. So if that and that, we've got that, and I'm making it a parallelogram, it sort of works out the same way, that it's the diagonal of this parallelogram. It's not to scale, so it's not perfect, but you get the idea. Okay, you should now be able to do exercise 2A on page 19.